first of many chapter lecture video presentations. This is Cosby and Bates, Chapter 1 for Research Methods, Psych 3040. Chapter 1, Scientific Understanding of Research, Thinking Like a Scientist. Don't forget that when you review these slides, not these ones here, but the slides posted in PowerPoint, please make sure to view them in presentation mode to click through the content and to access hyperlinks. So the one thing I wanted to first talk about and present to you is thinking about the human condition. Now, there is one thing that separates humans from every other species in our society here on this planet, and that is cognition. We have, not only do we have cognition, but we have superior or far more sophisticated cognition than any other species on this planet. And that allows us to kind of come up with questions and really try to figure out and think about the world around us. So every day we will bombard ourselves with different questions to try to make sense of what's going on around us. Like, do parking lots increase aggressive behavior? Or perhaps, why can't the Dodgers win a World Series? So because of this human cognition, we have a very curious mind where we're always trying to figure out and understand and make sense of information and things around us and our experiences. But not only are we bombarding ourselves with information, but we are bombarded with research findings every single day. But we have to remember that not everything that we see or read is true. So therefore, we have to have a very critical eye, using critical analysis, and critically evaluate content that is posted up there. In fact, being able to use critical evaluation and analysis has occupational value. We know that there's many jobs and professions where problem solving and solution-based thinking is valued. We know that public policy and Supreme Court decisions have been made because of research, because of people evaluating and critically analyzing research studies. In fact, a seminal Supreme Court decision, Brown v. Board versus Education, was actually determined based on a very important research study by Clark and Clark. So our Supreme Court justices critically analyzed research information and helped to come up with the decision on Brown v. Board of Education. Finally, we are also wanting to make sure we have strong research studies that have used critical analysis for program efficacy and program intervention. There's plenty of programs out there in our societies, in our communities, in our neighborhoods, where providing programming and interventions is very important. So being able to critically analyze maybe the best practices in a research study to understand sort of interventions to improve the quality of lives of people in our neighborhoods is very, very important. Now, unfortunately, not everybody is always using research findings or critical analysis to really come up with an understanding of the world around us. Sometimes we just know things because we believe in them. So sometimes we say, but I know it's true. And we heavily sometimes rely on things called intuition. Intuition is just our own personal insights that kind of verge on our own opinions that provide us with information about making explanations of behaviors and events. Remember I said that as humans, we're constantly trying to figure out the world around us. And so we're constantly trying to find explanations for behaviors and events. But unfortunately, what comes along with that is something called illusory correlations, also known as false associations. As you see here to the right, we have a picture of Serena Williams, who I'm sure you all know who she is. But Serena Williams, as an amazing athlete that she is, she still operates with an illusory correlation, and I'll explain it now. Serena Williams never changes her socks when she's engaged in a tournament because she believes if she were to change her socks, then therefore she would lose a match. So she's created this false association between the types of socks that she wears and whether she changes them or not, and her winning and loss outcomes. Now we know that she's an amazing athlete, and whether she has clean socks on and fresh pair of socks or not is not going to make a difference. It's her ability as an athlete that's going to make the difference. So she's really kind of has this intuitive feel or this false association between wearing socks and winning and losing. We also tend to rely on something called authority, where we kind of believe something is true just because it's posted somewhere where there's an authoritative figure. It's on the White House website, so therefore it must be true, right? I don't know. So anyone of authority or that uses an appeal of their authority to try to get you to believe in something that it may or may not be true, we have to be careful for that because we don't know if what's being espoused even has any scientific conclusions behind it. Now, the best way to critically analyze information is by making your own observations. Observe the information that you have, look at the data, look at the evidence, and form conclusions based on observations, data, analysis, evidence, information. That's the best way. So we want to really use empiricism to be able to make sense of the world around us. But unfortunately, sometimes people do still rely on that authority or that appeal to authority and try to make us believe things that we know are not true. So therefore, it's very important as a researcher to have a healthy dose of skepticism. Question and evaluate results, use logic, and don't believe everything that you read, because there's a good chance that it's not true. All right, so here's an activity for optional learning. You can go ahead and read that. Select an editorial. We're constantly sort of bombarded with information, even on our phones. I scroll a bit and there's some news information. So see if you can kind of find a news article and understand whether the author is coming from a place of intuition, authority, or trying to use empiricism and scientific evidence. Just an optional activity. Now, when we talk about the scientific approach is an objective set of rules for gathering, evaluating, and reporting information. Within the scientific approach, which is what exactly you will be doing in this class as you conduct your research project, has 4 different components, right? The scientific approach has data, it's controversial, it's important that you share this information, and it should also be peer-reviewed. So when it comes to data, we know we're going to deal with statistics and analyzing and interpreting results. When we say it's controversial, because we know that for every study you read, there's probably a dozen more that can refute a research study. So there's kind of a lot of conflict within studies, and it can be very controversial. Now, we know that we want to have peer-reviewed studies. We want our peers to be able to evaluate our studies, even when we're in the process of developing studies or getting ready to execute and conduct our studies. And more importantly, when we're getting ready to publish our work, we really want our peers to read and evaluate those studies to make sure that they're worthy of publication. Then, of course, as researchers, it's very important to share your information. And this is why we write manuscripts and have research papers, because we need to share that information to your peers, to colleagues, and to the general public, because likely you have found some really good information through your research project that illuminate and provide information to others and maybe even improve their quality of their lives. Now, during the research process, scientists must maintain critical analysis and scientific inquiry throughout the entire process. It doesn't just happen when you're getting ready to design your study or writing a hypothesis or getting ready to execute your methodology. It actually happens in the preparation phase, just where you're at right now, starting to think like a scientist and really starting to build scientific inquiry throughout. So what we see here, we have these little mice, and these guys are already thinking with scientific inquiry because they figured out an interesting phenomenon, that every time they press that lever, that postgraduate student breathes a sigh of relief. To learn more about the scientific method, go ahead and click on the picture here to link to a video on the scientific method. Critical analysis activity, something that we would have done in class or will be doing in class, is called the bank robbery, where you're going to carefully read a set of clues. So whenever you're doing critical analysis and critically evaluating content and information, first thing, read and review, review and review. Make sure you understand the content. You're going to analyze and apply strategies to evaluate information, and in this case, evaluate clues. And then, of course, you're going to figure out who robbed the bank, which is similar to finding solutions, having an outcome, coming together with a conclusion, and having results. Now, the goals of psychology, we have 4: describe, predict, causality, and explanation. These 4 goals of psychology are always met within the research process and in the scientific method. The research process allows us to be able to describe or to provide descriptive information and relationships between events, between variables, between people. Research process allows us to make predictions. We can now predict, because we've researched and collected and gathered lots of data, we can predict and anticipate behaviors and events, and this helps for decision making. Research process always provides us with this notion of cause and effect. So causality is very important when we're conducting research studies. It helps us to understand what causes a change in behavior. What are the best programs to improve the quality of life? What tools or measures and interventions should we use that are really going to be efficacious for some kind of an issue? So causality is important. And again, the research process allows us to uncover those things. Now, explanation, that really comes from the results of our research studies. Why things occur. The explanation is the conclusion, is the results, are the outcomes of your research study. And the outcomes of our research study in our results section always gives us a great explanation of that early research question and hypothesis. Now, there's a couple of things that we need to know about here, some basic pieces of information that we will continue to talk about throughout this semester. The first one is called covariation of cause and effect. Covariation of cause and effect establishes that indeed, in fact, that there is a cause and effect relationship between two variables. So we really want to make sure that the variables that we're selecting as researchers have some type of cause and effect relationship or covariation that exists between them. Temporal precedence is another term that we're going to be talking about throughout the semester, especially when we talk about things like internal validity and developing independent variables and dependent variables. Temporal precedence is really establishing the notion that the cause did indeed happen before the effect. It didn't happen afterwards, but that the cause, also known as the independent variable, had some type of an effect on the dependent variable. Then throughout the research process, we're constantly always looking for alternative explanation. Again, that comes into our scientific inquiry and critical analysis and thinking like a scientist. We always want to make sure that we're looking for all different types of avenues and ways of thinking of alternative explanation. Now, we have two different types of research, both basic and applied research. Our basic research generally is trying to answer research questions about the nature of human behavior and mental processes. So things like cognition and motivation and learning, personality, social behavior, and neuropsych. So an example of that is the effect of negative performance stereotypes on learning. And we can see here that stereotypes is part of our social behavior, and well, learning is part of our cognition and learning. Applied research is very different from our basic research in that our applied research tries to answer research questions to address everyday practical problems and to try to figure out everyday quality solutions to issues that are going on in our communities, in our societies, in our neighborhoods, right? The overall goal of applied research is improve the quality of life and develop new systems, new structures, new interventions, new programs, and even new technology. So an example of applied research is targeted smoking cessation messages for adolescents. And as you can see here, we're really trying to think about how do we come up with new messages to get adolescents to stop smoking, or perhaps in our world today, to not even start vaping. So that's applied research. Finally, this is our last slide here, and just a quick activity to kind of go through these 1 through 6 and try to figure out, are these basic research or is this applied research? So I suggest you have a go at that. And with that, we're done with chapter 1.